Section 6.1, example number 3. The problem says the current in a 25 millihenry inductor is known, and it is given to be negative 10 amperes for t less than or equals to 0 is negative 10 cosine 400t plus 5 sine 400t e to the negative 200t amperes for t greater than or equals to 0 plus. So the current expression is given. The problem says at what instant of time find the time t where the voltage across the inductor is maximum. Find t where Vmax happens or the voltage is maximum. Now it also asks as a part of B, what is the value of the V maximum? Okay, as you can see, the expression for current is given and the value for inductance is given. So we can pretty much apply V equals to L di by dt formula. Okay, once you do that, what you will see is you will get an expression of voltage in terms of time. Okay, this is going to be an equation, this is going to be a curve. Now, in order to find the time at which this curve is maximum, okay, is that you take the derivative of this function v of t that you get from the previous step and equate that to 0. Okay, once you equate that to 0, you can simplify to find a value of time where the V maximum happens, because we know from calculus that the maximum or minimum for a particular function or a curve happens when the slope of that curve is 0. Okay, that is what we are doing here. We are taking the derivative, which is the slope, and equating the slope to 0. Once you get that, once you get a value for t, you can plug that value into the expression here, and then you'll get a value for V maximum. Okay, let us see how we go about doing that. So we start by writing V equals to L di by dt. Okay, now we know L is given to be 25 into 10 to the negative 3 Henry. Okay, and d by dt of the current, which is given to be negative 10 cosine 400t plus 5 times sine 400t times e to the negative 200t. Okay, e to the negative 200t. That's the expression for current, right? So let's see. So this is current e to the negative 200t. Okay, now we can simplify this using the chain rule. There are two functions here. It's a composite function. There is a e to the negative 200t, and then there is this entire component. So we can apply the chain rule when calculating the derivative, and then independently apply the derivatives for each of those. Okay, so I'm going to follow a few derivatives steps here, and then arrive at the final solution, negative 10 to the 3. I'm simply factoring out the negative here, and then I can write this is going to be, we start by finding the derivative of the e to the negative 200t, which is e to the 200 times e to the negative 200t, okay, and then multiply that by the same function, cosine 400t plus 5 sine 400t, okay, and then we leave this alone, e to the negative 200t alone, and then derive the green component, which is going to be minus 4000 sine 400t. So that's the derivative of the cosine term, and then plus 2000 cosine 400t. Okay, so what I have done is to simply this part is the derivative of that is shown there, and the derivative of this guy is shown here. Okay, so clearly we are applying the chain rule here. Now we can simplify this a little bit more. I'm going to leave that as an exercise to you. Eventually, what you will get is that the expression for V of t, the voltage across the inductor, is going to be 125 e to the negative 200t, okay, sine 400t. Okay, so this is the expression for voltage across the inductor as a function of time. Now, what is our strategy? Go back to the strategy. Once we have this expression, we want to take the derivative of it, right, and equate that to 0. Let's go about doing that. Okay, let's take the derivative of V of t, derivative of V of t with respect to time. Okay, that is going to be d by dt of 125 e to the negative 200t times sine 400t. So we apply the chain rule one more time and then equate that to 0. Once you apply the chain rule, what you will see that all of this is going to be 125. Okay, so all of this is going to be 125 into negative 200 times e to the negative 200t, and then I leave the sine 400t as is, plus 125 times e to the negative 200t. Now I do the derivative of the sine, okay, which is going to be 400 cosine 400t. Okay, so what we can do is we don't want to oversimplify this. We are interested in equating this to 0. Okay, equate this to 0. You'll see that this simplifies to 2 cosine 400t equals to sine 400t. Okay, or sine 400t by cosine 400t equals to 2, or 400t is arctan or tangent inverse of 2, or time equals to tangent inverse of 2 over 400, which is going to be 2.768 milliseconds. Voila! So this t equals to 2.768 milliseconds. Now, this is one of the problems that we are interested in, one of the parts of the problem that we are interested in finding. Find the value of t where Vmax happens. What did we do? What we did is to find the expression for voltage and take the derivative of it and equate it to 0. Okay. Now, what's the next part of the strategy? We take the value of the t that we have and plug it back into the equation. Okay. Let's see the equation for the expression for V of t equals to 125 e to the negative 200t sine 400t, because that is what we found out, right? We got the expression for the voltage like so. Very good. Now what we do is to plug in the value of t equals to 2.768 milliseconds into this. We'll get the value of Vt maximum, okay, or V maximum is going to be a value of 64.2748 volts. Okay, so this is the other part of the problem. So all we have done is to use V equals to L di by dt, and then take the derivative of V, equate that to 0. Once we get a value for t, plug that in to the expression for V of t. Okay, straightforward problem.